This is the problem. Essentially, in a ship unloading operation, we're unloading a 3,500-pound automobile by a cable, and a worker ties a rope to the cable at A and pulls it in order to center the automobile where he wants it to land. At the moment pictured in the picture, the automobile is not moving, the ring is not moving, and neither is B. And the angles between the vertical and horizontal are given there as 2 degrees and 30 degrees. So in our Python and statistics, we're looking at equilibrium of a particle with 3 forces. I did GeoGebra.org and got our solutions for TAB and TAC. And in Python, I used law of sines, got the same values again. And we looked at components. When we did components, we had 2 equations and 2 unknowns. So I did a linear algebra solution and a symbolic solution, and got the same numbers that we had before. There's still another way to do it. One more way, looking at it, let's look at our free body diagram. And if we, instead of making x horizontal and vertical, we can align the x-axis with TAC and the y-axis perpendicular to that. When we do that, we'll notice the angle between our weight and our x-axis is 60 degrees, and the angle between our y-axis and TAB is 32 degrees. So we can do some of our forces in y now. Again, this is a different y. We see we've got TAB times cosine of 32 in the y direction, and we'll have a component then of the weight going in the negative y direction, and it's the opposite side of the 60 degrees, so it's sine 60 degrees. Now here we only have one unknown, TAB. So we can actually solve for TAB. It's W sine 60 divided by cosine of 32. Now we can do some of the forces in our new x direction. And we see TAB times sine 32 going in the negative x direction. Our W times cosine of 60 in the positive x direction. And our TAC is moving all the way in the x direction. So it's here. Again, we know TAB from this first equation, so we can then solve for TAC. So we have now 2 equations to solve. I'll write them again over here. Bring Spyder back. Again, from math, import star. Import everything. So we just want TAB. Let's define W. W equals 3,500. And TAB equals W times sine. We still need our radians. 60 divided by cosine radians 32. And our TAC equals, again, now we know what TAB is, it's just a number, times sine radians 32 minus W times cosine radians of 60. So we can again look at TAB and TAC and see that we, whoops, TAB, oh, I did 6 degrees instead of 60 degrees. So let's go up. I use the up arrow key to go back in previous commands, and I'll change that to 60. Now check TAC again, and we got our 144 again. Okay, one more thing we could do, we'll do with this one, just to show you don't really need the things. We could actually use a spreadsheet. So I'm going to say W is 3,500 pounds. Then TAB and that will be W, but instead of W, I want an equation, so I start with an equals, and our W here is what's in this cell A2, and I'm going to multiply that times sine, and in a spreadsheet you need to do the same thing you did in Python. 60 divided by cosine radians 32. And likewise TAC, and again we want an equation, so we start with equals, and our TAB value is over here in B2 times sine radians 32 minus, again our W value is here in A2 times cosine radians, and let's make sure we do 60 this time and hit enter, and there's the values in a spreadsheet. Okay. Oops. I hope you enjoy working statics problems with these computer tools. Thank you.